All right, so here's section 2.5. And again, we're proving things about angles, specifically angles being congruent. All right, so we have a vertical angle theorem. So we've used this already, but we haven't proven it. And what the theorem says is that vertical angles are congruent. We want to come up with a proof. So I'm going to need to come up with a general case that makes this work. All right, so we're trying to prove it for every type of angle that's vertical that they're going to be the same. So I start with a picture. Intersecting lines. Who can raise their hand and tell me two angles that are vertical to each other given that picture? Ellie. A and B, is that the only ones? What else do we know? Devin. C and D. Good, so they're vertical. We don't yet know that they're congruent. So we have to take this picture and we have to show why they're the same, why they're congruent. All right, so we're given A, B, C, and D are formed by intersecting lines. And I'm going to divide this up into what's called a two-column proof. I have my statements on the left, and I have to put my reasoning on the right. So my first statement is that A and C, measure of angle A and C, add up to 180 degrees. My second one is that C and B add up to 180 degrees. And I want to think about, why is that true? What am I saying that makes that true? What's my reason? Alex, what do you think?
Would the first one be given?
Not quite. Usually we do start with a given. What type of shape do A and C form?
A line.
A line. And what's the angle degree of a line? 180. All right. So that's my definition of a linear pair. So one of the problems from the last problems that asked you to define linear pairs. A linear pair are two angles that make up a line. So these are next to each other. They make up a line. I know they're a linear pair. All right. Well, I can conclude something using that information there. I know that measure of angle A plus measure of angle C equals measure of angle B plus measure of angle C. What property of equality am I using to make that statement? Alex? I could talk about it as, did I say transitive here? Not quite. Not quite transitive. No, I did say transitive. Did I get that right? Let me think. Yeah, I'm sorry. Yes. I thought maybe I had it as as substitution. I couldn't remember what I wrote down. So if this is equal to 180, I could substitute out 180 for this piece and put it in there. That's what I did here. All right, sorry. I'll get my brain woken up. All right. So I have measure of angle A plus measure of angle C equals measure of angle B plus measure of angle C. How do I get to the next line? Measure of angle A equals measure of angle B. Which property of equality? Subtraction. Right? My subtraction property of equality. Well, if the measures of A and B are the same, what do I know about the angles? Remember, we want to show that they're congruent. If the measures are the same, what can we conclude? Yes. And we say that they're congruent. A is congruent to B by the definition of congruence. All right. So we've shown for any case that A is going to be congruent for B to B. So any vertical angles are going to be congruent. We have a proof for it. And if you set it up has two columns. It's really easy to see where your reasoning and what your statements are. All right, thumbs up, sideways, or down in terms of the understanding what we did. Thumbs up, sideways, or down in terms of the presentation, how I went about it. That's going to be the tricky part. Okay. All right, I want to try another one with you. Congruent supplements. So here's a theorem. This is what it states. If two angles are supplementary, or supplements of the same angle, then they are congruent. So if two angles are supplements of the same angle, then they are congruent. So this is one of the first day I said we have to learn how to read the math language. So we can pick it apart. Who can tell me what supplements mean? What angles are supplementary? Yeah, Devin.
Like two angles that add up to 180?
Yep.
It's an if-then statement.
It is. So we're proving these if-then statements. We have a conditional, now we want to prove it. So if they add up to 180, and they add up to 180 with the same angle, then we're going to say the angles are congruent. We're going to prove it. I'm going to start with the statement, and I'm going to have a reason. My first statement, measure of angle A plus measure of angle C is 180. Measure of angle B plus measure of angle C is 180. How do I know that? What do you think? This was Alex's first answer. It's given. This is what the hypothesis of this conditional says. Two angles are supplements of the same angle. Two angles, A and B, supplements of the same angle, angle C. So this is given. That's the hardest part of this proof. It's the first step, is the setup. So if I start with that, I want to show that A and B are going to be congruent. So if both of these are equal to the same thing, then this has to be equal to each other. And this time I did use substitution. All right? So where I see 180 degrees, I can take that out and I can substitute in measure of angle A plus measure of angle C. I use the substitution property. If I want to get A and B by themselves, what do I need to take away from both sides? C. So I subtract it. My reason is my subtraction property of equality. I'm not quite there yet because I want my statement to be they're congruent. Well, if the measures are the same, then A is congruent to B because that's my definition of congruence. All right? And as a total aside, sometimes if you guys keep taking math classes, you'll see proofs with the QED after it. That's Latin for quaderat demonstratum, which means it has been shown. Sometimes people think it stands for quite easily done. But it's something that comes at the end of the proof. You don't have to put it, but I wanted to show it in there. That means that you showed what you set out to show. We started with this. If two angles are supplements of the same angle, then they're congruent. All right. Your turn. Here's the theorem. All right angles are congruent. You need to prove it. Now, this is traditionally where, so we look at it, and it's hard to tell where to start. But let's think about, what are we talking about here? How many angles am I going to at least need to be able to prove this thing? 2. And what type of angles do I need?
Right.
I need right angles. So I'm going to start with another theorem, apparently.
Okay.
All right, we'll come back to this one. Okay, I'm going to start with my two-column proof because it's easy for me to figure out what the statement is and what the reason is. And I'm going to start with one 90-degree angle. That's going to be given. That's fine. And I need another one. That is also given. So with that information, somehow I need to figure out that A and B are congruent. Well, what conclusion can I draw between those two first lines? Yes. And why do I know that? Okay, and I can substitute, right? Yes. So I substitute. Well, if the measures of two angles are the same, what do we know about those angles? They're congruent. And why are they congruent? Because that's what the definition of congruence says. So there's a proof. Now we can use the fact that all right angles are congruent. We start with something that's given. We want to end with the congruent part. All right, nod your head if it looks simple when you see it done. All right. It's hard to start, though. I know that that's true. So try not to get frustrated. All right? Try to play around with something. See what you can assume. See what makes sense to start with. And then you know where you have to go with it. All right. We have another one that I want you to try. So if two angles are congruent and supplementary, then each angle is a right angle. I'm going to give you 3 to 5 minutes to work on that. With those around you, then we'll come back and we'll talk about what my proof looks like. Your proof might not look like my proof. We want to take the piece after if, before then, and we can assume that to be true. That's going to be our given. So how many angles am I talking about? 2. And they're congruent and they're supplementary. That's a lot of information. What does supplementary mean again? 180. So let's see what we're given. A is congruent to B because it's given. Measure of angle A plus measure of angle B is equal to 180 because it's given. All right. How did I get from the line above here, something that was given, to this here? What did I do? Alex? I substituted. All right, I took an equivalent measure and I put it into the same equation. All right? So there's my substitution property. Well, measure of angle A plus measure of angle A is 2 times measure of angle A. That's our definition of addition. We just simplify it. What allows me to get to 1 measure of angle A? Divide. And what property we have? Division property of equality. All right, I can divide by the same quantity on both sides. It's the division property of equality. So if the measure of angle A is 90 degrees, what can you conclude about angle A?
It's right angle.
It's a right angle. You can also conclude measure angle B. And these are right angles. And the reason is, that's the definition of what a right angle is. An angle that has a measure of 90 degrees.